If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SPE sponsored podcast.
Good morning. Now it's officially 4 minutes after morning where you are.
It's still that's true. So we're in that hybrid morning, non-morning stage.
I love when you recognize Central Time. I
hate Central Time. It is the bane of my existence, and I will never conform.
So what are you? You're in PA, so you're Eastern.
I'm Eastern.
Where are you, Mercedes?
I'm in Chicago.
Solidly
Central Time.
So I despise Central Time because I will always set up meetings and forget that Central Time exists in general.
So anyway, I'm Mercedes Landazuri.
And I'm Lynzie Nebel.
And with our powers combined, we are
PlastChicks.
The voices of resin.
Yes.
And go ahead.
Well, I was just going to say, we release our podcast the first Friday of every month. I think I'm just jumping in on your lines this morning because I'm just feeling, I don't know, eager, excited. It's a rainy day.
Again with the morning.
It's not morning. It's whatever. And you can listen to our podcast first Friday of every month, or you can watch the YouTube version of it, which is usually released a couple weeks after, just in case you want to see the frustration on my face when I realize that it is not still morning time in my time zone. But you can listen to our podcast anywhere that you get podcasts. You got Spotify, Google, Apple Podcasts, Google, yeah. all the usuals, or the YouTube
podcast places.
All the podcast places.
And in our podcast, we talk with people who work in the plastics industry or plastics industry adjacent.
Are just a big fan.
We have a very nice guest today, and I'm not even sure if our guest, which time zone our guest is in. Is it still morning for you?
It is not. I'm Eastern time zone as well.
Oh,
I am in Atlanta.
Team Eastern time zone. Well, this morning we have Mitch Rife. He's the engineering manager for Additive Manufacturing at Delta TechOps. So welcome, Mitch. Thanks for joining us on our delightfully chaotic podcast.
Thank you very much.
I believe, Mitch, though, even though you are in Eastern time zone now, I believe you are a native Central timer.
I am. Correct? Can you tell in my voice?
I did a little research on you, and I saw that you had been one of my neighbors to the north over here.
Yeah, I grew up in the Upper Peninsula of Michigan. A huge Green Bay Packers fan, though, because I am on the western side of the Upper Peninsula of Michigan. If you're on the eastern side, then most people are Detroit Lions fans, which I feel sorry for them for the last many years. Upper Peninsula, Michigan, then lived. My first job in aerospace was in Peshtigo, Wisconsin, which is just across the border from the Upper Peninsula, Michigan. Known for Peshtigo, Wisconsin, is known for it was the worst fire in United States history in terms of loss of life.
Wow!
Most people wouldn't know that it happened the same night as the Chicago fire, but more people died in Peshtigo.
Wow, I didn't know that, but Chicago, we like our stories. I've never heard of the Peshtigo fire.
That's literally going on your things to look up after this, isn't it, Mercedes?
It is.
We didn't have a Mrs. O'Leary or a cow. That's why it didn't work out.
You know what? You need a shtick to start the fire, and then. So, Mitch, can you tell us a little bit about your background? We kind of touched on the fact that you are a Midwesterner at heart and start, but can you tell us about how you got into aerospace, how you got into additive manufacturing?
So really, aerospace was kind of just kind of happened. I was a machinist. I started out as a machinist. I took a job for a small aerospace interiors company. In Peshtigo, Wisconsin, as a CNC machinist and programmer and setup. Back then it was called ERTA. We did designed and manufactured aircraft seats for VIP which is really like Dassault, Falcon Jet, Gulfstream, Cessna, larger business jets, but really more for the private sector, not commercial aviation. And when I started, there was some 3D printing. We didn't have it in-house. It was hugely expensive, but we did some externally when we would develop prototypes. So it kind of fascinated me because I also designed as well. I've always been a maker, and I would design, and it's like, how do I get this made faster? How do I understand if this is going to work more quickly? And from going from a machinist, then I moved into engineering. And then it was, okay, from a design perspective, I need to know if this is going to work faster. Okay, you can do your typical manufacturing methods, and it just was never fast enough to, in product development world, the faster you can fail and the faster you can iterate, the better off you are.
Mm-hmm. And you studied machining and in school, but where did you learn 3D printing?
So 3D printing was kind of just, I picked it up, started, like I said, it would have been early 2000s. I started at ERTA in 98. I moved into engineering in the early 2000s. And the first printing, we printed shrouds for basically it was a prototype aircraft seat. We needed to do all the shrouding and everything for it. So that was all done SLA. And that was back when, there was only SLA and FDM. And only you had big players like 3D Systems and Stratasys were really the only players in the market. And it just fascinated me. So I started getting a little more into FDM printing initially, because it was really the easier to get into. As a machinist, it's all G code. It's all, programming, and 3D printing. It's all G code, G and M code. So it's very similar with regard to, one is subtracting material, and then 3D printing is adding material. So it's not, in terms of the process, yes, it's the opposite, but the thought process is very similar. So
I was gonna ask you about that, going from a very subtractive to literally an additive process. Do you have to retrain the way your brain thinks about production or, manufacturing of the part?
not really. For me, maybe for others, but I don't think so. Most machinists that I talk to, a lot of machinists that I know have 3D printers at home. I think it's really just another tool in the toolbox, and it's a powerful tool, especially if you're working. Like I have a home machine shop and home additive shop, and I may end up machining parts for a customer, but initially I may 3D print all of them just to get the idea across, because usually I end up being the person that they send me an idea, or we talk about an idea, it's on a piece of paper, and then turn it into 3D CAD, then turn it into 3D prints, and then go to traditional manufacturing if that's what it needs.
Yeah, I never really, I feel like people kind of think they need to choose one method or the other, like whether you're machining parts or like, printing parts. And I feel like, what you're displaying is kind of this like beautiful back and forth that I feel like gets missed a lot, at least maybe in injection molding. I feel like, we see it as like, we're going to machine this, or we're going to, maybe make a prototype out of 3D printing, but I don't see that, that relationship come as far as I feel like what you're describing. Do you kind of, do you lean one way or the other when you're, or do you see other people leaning one way or the other when you're kind of talking about designing a new part and the product development part of it?
Yeah, so from a prototyping perspective, everybody's always fine with 3D printing.
Right.
But from a production perspective, I tend to get pushback from people who don't understand basically the 3D printing process, what the materials are today, as compared to, years ago, or they may have seen, you see a lot of people just printing like figurines and, little things where there's materials, very high engineering grade materials, that can be utilized. that people just don't understand are there or exist.
Yeah.
So it's really about teaching that along the way. People who aren't into 3D printing always think of it as kind of a toy, something just a prototype versus production. But that's where I come in and kind of explain this is what we can do with 3D printing, how we would do it with 3D printing. So one customer I have, I do light bezels for, custom light bezels. And this is my personal business. And because he only needs a couple hundred here and there, it doesn't make sense to injection mold them. And once again, it's a light bezel. It's not, and the light that it's actually going on is an LED. So there's no heat from this light. So it's not a concern. So really I'm looking at, I don't want it to weather over time in terms of, yellowing. So go with the material that's UV resistant, is flexible, light, and he pops those in and calls it a day.
Yeah.
So
much easier.
Yeah, it's much easier. Now, if he was doing thousands of them, then injection molding would be a better route. And the nice thing is that working with this customer, I was able to go through, design everything. It's all in 3D CAD. It's all 3D printable, but I have it all set up parametrically where if he ever decided he wanted to do injection mold, I can throw the draft on, send it out for bid, and there we go.
Well, see, that is something I feel like a lot of people also miss, in the moving from 3D printing into injection molding. A lot of people will, separate the two, and then we see stuff coming in as, oh, I had this, 3D printed, it's fine. But hearing like that you have it set up for the next step in the process already with that in mind is like, it's such a myth sometimes.
Yeah.
It adds to the process.
Right. You have to think about where your lifter is going to be, where's your screw going to be, where your ejector pin's going to be. And if you think about all that ahead of time, you could design it for 3D printing, but be ready to go straight to injection molding if it ever occurs. Where are my slides going to be, and how many slides am I going to have? How much is this tool probably going to cost?
Right. And
so
I think, go ahead, Mercedes.
Oh, I was just going to say, Mitch, let's get back to your work with Delta. Can you tell us the advantage of working for Delta Flight Products and being involved with innovation for the airline instead of working for the broader scope?
So I did switch. I'm now at Delta TechOps, Delta Airlines. I still work with Delta Flight Products a lot. I started at Delta Flight Products, which is a wholly owned subsidiary of Delta Airlines, but it's separate, more of an innovation house, more production, where Delta Airlines flies planes, fixes planes, maintains the planes. Delta Flight Products creates products for the aircraft interior, whether that be in-flight entertainment, whether that be monuments, whether that be something we'll talk about in the near term with the PRM accessible seat. That is really what Delta Flight Products does beautifully. And here at Delta Airlines, Delta TechOps, it's maintaining and flying the planes. But so here at Delta TechOps, what I like, kind of moving back a little bit out of the scope because it's for the airline side, is we do a lot of 3D printing internally. It's not necessarily parts for the aircraft yet. We have done a few, but the majority of what we do is really to support the operation. The mechanics on the floor working on the aircraft, working on the engines. They need special tooling that, if they go out and buy it or had somebody else make it, it may be, tens of thousands of dollars. We have parts on the shop floor that move around that are, anywhere from $5,000 to $250,000 parts. An engine costs millions and millions of dollars. And those parts, we do part protection for those. So as they're moving around the shop, we print a ton of TPU parts to protect.
And you mentioned
engine
that was super surprising to me that it was so much TPU. I think I would not have thought there was so much TPU, and I'm sure the average, non-additive manufacturing person definitely doesn't expect TPU to be printed as often as you do.
Because a lot of times we're protecting things during movement, but you're not protecting thousands of things. You may have this engine component, you may have 20 of them in the shop. It doesn't make sense necessarily to tool up and do, let's say, a silicone pour or a rubber pour for 20 parts. And depending on the engines, we may only do 20 of those parts a year. And once again, additive just makes it so much easier. And TPU is the perfect medium in terms of a protection perspective. And also think about it from the shore hardness. TPU, okay, it's 95A, let's say, or it's 74D or whatever it might be. But depending on the infill that I put in and how many walls I put on it, I can change that. The material itself, if it's printed solid, yes, that's the shore hardness. But if I print a certain thickness with an interior infill, I can change that and make it very, very soft, or I can make it very, very rigid.
Very cool.
So we do it for part protection. We also do it for physical protection. There's big fixtures all over the shop that mechanics are working with where, just like your refrigerator door, you open up your freezer and then you go in your refrigerator and then you stand up and you hit your head on the freezer door that you forgot you had open. Or the cupboards. We do the same thing with fixtures and stuff here that could happen, and we'll print, safety or protection out of TPU so that people aren't, hitting their heads and then going to the hospital.
I'm as most people know, I have 4 boys, and my second oldest had 2 head injuries this week, completely unrelated. And I'm thinking I need myself a printer.
Yeah,
printing some TPU protection around here.
I have a spool sitting right over here. Lynzie. Send me some dimensions.
Some corner covers. We need some toy box covers. I mean.
So I'll back up a little. I know we're going tangent all over the place, but
that's how we do.
So it was a little over 2 years ago that I was asked, hey, would you be interested in coming to run or manage the 3D printing lab at Delta TechOps? I was at full-time Delta Flight Products. I was engineering manager of product development there. And I said, because they knew I had a lot of background in 3D printing. Like I said, I have my own 3D printing lab at home. I can go through the whole list of printers I have at home because you start buying them and pretty soon you don't stop and they're everywhere.
I get it.
But so initially the lab here at TechOps started in 2016, and the initial focus was on metals. And rightfully so. I mean, engine maintenance, you think, okay, how can I make engine components? Now, that's been very difficult because there are a lot of regulations in place when it comes to engine components, which there should, because you're talking safety of flight, a lot of passengers on a plane. As we know, flying is still the safest way to travel, and there's a reason for that. So that was worked on for 4 years, looking at how we could 3D print engine components out of metal. So, laser powder bed fusion. And it was a good exercise, but it didn't, in the end, really bring an engine component to life, let's say. So then COVID hit, as we all know, and Delta had put a package together, people who wanted to leave. Nobody was ever, one thing that was great about Delta, nobody was let go, nobody was furloughed, but there was voluntary retirement packages that occurred, and people took those. Especially, we have a lot of people that have been here a long time. You'd be surprised how I can walk down the floor and every five person or fifth person that I run into has probably been here for 20 years or more.
Wow.
The lead in our shop has been here for 42 years. So a lot of people, 42 years. A lot of people come to Delta and stay to Delta because the culture it's always people first. It's always safety first. It's an unbelievable culture. I've never experienced it before. but anyway, many people left. So they needed, they asked if I would come and look at the shop and see what can we do? Is there something different we can do? And when I came in, there was Stratasys, Fortis 450, two Ultimakers, Azor Trax.
Never heard of that one. It sounds like a villain.
It's made in Poland. I'm not a fan. Some people are. It broke, I think, the first week I was here, and I donated it to Delta Flight Products, and they got it running again. But we ended up, I said, why aren't we printing tooling? Why aren't we printing fixtures? Why aren't we printing part protection? We do sandblasting, shot peening. There's fixtures all over the shop that are protrusions of metal, and some places you got to wear bump caps, but some places you don't, and just a plethora of things that could potentially 3D printing could solve. I mean, a lot of low hanging fruit. So that was the direction. I brought my principal engineer from Delta Flight Products over, and then we had another gentleman that was already still here. He stayed. He was a mechanic, but he got into 3D scanning and 3D printing on the side. And he was in doing a lot of the design work. And so anyway, we started a campaign. It was internal marketing campaign of 3D printing. What can we do? How can we help you? Come to us with any and every idea. And we set up a smart sheet forum. We did some basically meeting with engineers, meeting with mechanics to talk about 3D printing and what it could do, showing examples. So then people started coming in. When we started in here, there was 5 projects per month. We range anywhere from 80 to 120 projects per month. And that's not parts, that's separate projects.
And you have a fairly small team for the amount of work you're putting out, right?
We have 3, well, it's myself, and then I have 2 engineers. Then we have 3 AMT tool design technicians, but they're 3D CAD, setting up the 3D printers, so on. So let's see, there's 1, 2, 3, 4, 5 people designing and setting up printers, and then there are 2 people that are our lead, and Shane, our mechanic, another mechanic that sets up our metal machines and also does post-processing. We have a small mill, lathe, shot blast, sandblasting and glass bead, vibratory finish, so on, that we can post-process at least somewhat metal 3D prints. That's our team, and it's a lot of printing. We're also just bought a pressure former, it's the Mayu. It's a small pressure former. Basically, some of the covers we make are simply very thin just to protect something, and we may have to do 100 of those. It doesn't make sense to print 100 of something that is TPU, but it doesn't necessarily need to be TPU, but it needs to be flexible material. Well, it takes, let's say it takes 6 hours to print one. Well, in that 6 hours, we could have pressure formed or vacuum formed all of them.
Right.
So once again, what makes sense for 3D printing, and when does that volume get to a point where a more traditional manufacturing method makes sense?
Yeah.
Same thing, silicone molding. We do a lot of plasma spray here, which is it's a high heat process, where we'll design and print tools that then we're pouring silicone. And the final part is a silicone part because of the heat. Other times we'll actually 3D print those parts out of Ultem for the high heat, because the geometry just requires something that's a little more rigid. So then we'll use like an Ultem 9085 or an Ultem 1010, even high temperature nylons, depending on what it is or where it is.
Hi, I'm Dr. Sarah Skidmore, and I'd like to share with you SPE's Certificate in Leadership. Have you heard about the program? In this program, participants learn about essential leadership and management principles, such as organizational culture, financial intelligence, strategic planning, innovation, and more. But they not only learn the topics, they learn how to apply strategies and tools to their team, their department, and organization. I invite you to visit 4spe.org to learn more about the certificate in leadership and to apply for an upcoming cohort.
Very cool. So I heard that you worked on a wheelchair accessible row. Can you talk about that project and the importance of equity when designing an airplane interior?
Yeah, so this was really fun. So product development, it's we'll go here. It was 2021. I want to say January or February of 21. So we're still in the throes of COVID, obviously. Trying to figure out Delta Flight Products, a product company, making aircraft interior products, and nobody's really flying. So we're looking at, other ways we can, help the airline, but also from a product perspective, other things we could do. Our president, Rick Salinitri, walked into my office and he said, "Hey, I got a call from this gentleman, Chris Wood, from Flying Disabled. And he's talking about a wheelchair accessible seat." And I'm like, "Okay." He said, "Well, talk to him and see what you think. Let me know." So I talked to him. I gave him a call. He's over in the UK. And he has both of his children are in wheelchairs. And, and he's got a nonprofit called Flying Disabled that he's been basically spearheading and really working with the industry, many industries, but especially aviation, because access for the disabled in aviation is difficult. There are some rules in place, but the equity isn't there. There's reasons for that. But over time, you need to work on those types of things. You need to find how do we as an industry make flight more accessible to everybody. Anyway, he had a good idea. He had been working with a design firm in England as well called Priestman Good. Also one of their basically a certification house called SWS certification. They were kind of their own they started their own consortium, and it was called Air for All. Mm-hmm. And Priestman Good had worked with Chris to kind of design a seat that could basically be a person could come in on their own powered wheelchair. We kind of focused on power, or they had focused on power initially, and I'll kind of talk about the reasons for that. But they had done kind of the industrial design. So how would it look? How would it function just and how would it look in the aircraft, and a lot of the idea side there. What they came to us for was the engineering and the manufacturing side, and understanding the certification qualifications that you have to go through to put something on an aircraft. So great conversations. It started off slow like anything else would. But then we really started getting into it. And I talked to our president, Rick Salinitri, about it. He was like, "Yeah, this is something we really need to look at doing and see where it can go." So I said, "All right." And we started down that path. And we ended up designing a prototype for that seat that went to the Aircraft Interior Expo in Hamburg, Germany this year.
Oh, wow.
And a fully functional prototype, not something you could put on the plane, but basically it's a seat that the inboard passenger seat pan folds up. You take the cushions off, it folds up. It's on we call it a plinth, but think about it like it's on the floor. It's a pallet that has the belts in it that then attach to the wheelchair, just like it would in a bus or a train or anything else, basically to hold it in place. That locks it down. Now, one thing, and this is where you kind of think about, how do we make this work to really make the experience equitable, or the same experience for somebody in a wheelchair as it is for somebody who's not. We want that experience, that flying experience, at least when you're there sitting as a passenger, to be the same. So a couple things we did when that seat pan folds up, the armrest actually raises up and moves forward, because inside that armrest is a tray table. So if you're going to get something to eat or drink or whatever it is, every passenger has a tray table. Now with that, with the wheelchair there, the wheelchair arms set up higher. So the tray table couldn't be utilized unless we were to have that actually lift up and move forward. Now, one thing to let you guys know, a lot of people probably don't know, is aircraft seats get crash tested. They actually go down a sled with an ATD like a car has, a crash test dummy in it at 16 Gs.
Really?
Wow.
And it has to go through rigorous testing. The other thing with that as well, when this wheelchair and that occupant are on board and they're actually locked in, that has to withstand 16 Gs with regard to what we call item of mass retention. So let's say that wheelchair and occupant is 500 pounds or 600 pounds. We have to prove that's all going to stay in place during a 16 G crash. So it can't go flying, out. Obviously there's a person in it, so it can't go flying out, but it has to at 16 Gs, so that weight times 16, and it's going to have to stay in place and not go anywhere.
Wow.
And so there's a lot of engineering that goes into that, all those mechanisms, everything else. Nothing can come flying off the seat. It can deform, but it can't break. Anyway, there's a lot that goes into that. But once we've went to Hamburg and the seat was shown, and it got a lot of attention and a lot of people interested in it, and rightfully so. I mean, we need to do more of this in aviation and make it, like I said, more equitable. One big problem that passengers with, and you can look this up in there's articles all over the internet of people's wheelchairs being damaged because they get put in a cargo hold. That cargo hold, most cargo holds aren't tall enough for a powered wheelchair to sit straight up. So they actually have to be laid on their side. And as we know, turbulence, everything else, things aren't locked down properly, they'll break. And a lot of these powered wheelchairs are customized to that individual and their disability. And if that breaks and they get to the end of their journey and their wheelchair is broken, I mean, in speaking to a number of people, I mean, that wheelchair is their legs.
Yeah.
And now it's gotten damaged. Now, the only thing the airline can do is get a different wheelchair for that person, but that wheelchair they get them may not be the same type, and maybe they're left-handed, not right-handed, so the controls are on the wrong side. Maybe they have other issues where they have very special cushions in their seat that they no longer have. All of these things can be, detrimental to that individual.
Just devastating. It would just
yeah.
be can't even imagine.
Right.
So this is we've been working on this now for a few years. It's gotten the next round of funding to continue it. We're looking at early next year going into certification. That'll take the majority of all of next year certifying it. But I feel, at any point this could fail. There could be a problem with the certification. There could be a problem with installation. But I feel that in talking with regulators, in talking with DOT, I think there's ways around that this will someday be on an aircraft and really help. There's also the push for PRM accessible lavatories where an individual can right now think about how does somebody in a wheelchair, they're put into a seat, but they can't.
Right.
Currently, what happens is the person is taken out of their wheelchair and put into a wheelchair that can go onto the aircraft, and then they're lifted and put into a seat. And that wheelchair is stowed. It has to actually go into a compartment in the aircraft. It's a very small wheelchair. Now, what if that person has to go to the bathroom?
Yeah, that's so much pressure on that person, and it's so much pressure, like, is my wheelchair going to make it just fine? And did I have too much coffee or not enough coffee for today or whatever? That just makes me itchy thinking about if that was
Right.
my scenario.
And it's things that I didn't think about either until I talked to Chris. And like I said, both of his children are in wheelchairs, and understanding what a person in a wheelchair, what they have to go through to try to travel is just it's I couldn't imagine having to go through that experience. Many people I've spoken to, they'll actually dehydrate themselves prior to flying.
Oh,
Um,
which is terrible because you're already like, I feel like I'm the type of person that when I fly, I'm like, I need like extra bottles of water, all this, because I feel like I get dehydrated and headaches and the whole works. And
You
I
do a
can't
couple
imagine
Bloody Marys before the flight at the airport bar.
Bloody Marys may or may not have something to do with it. But like to have to like actively think about going the opposite way, that's heartbreaking.
Right.
and
Yeah.
yeah, and it is. It was absolutely heartbreaking. Listening to the stories and really understanding what people have to go through that are in wheelchairs, or with other disabilities go through that we just don't even think about. And that's it. And I think as a population, we don't think about it.
Mm-hmm.
I think people care about it, but it's just not a thought they have in their day-to-day lives. And I think putting more attention and focus on it is I've learned a lot. People around me have learned a lot, and Delta has been wonderful, funding this to do this work.
Yeah, I think that's
Great.
incredible, and the fact that Delta's standing up to say like, here's this big equity piece that we are missing. Let's take some serious action and create the prototype and get all the certifications. And I feel like sometimes some of these things, and not talking about Delta, but in general, we see things that are like, oh, here's this new product, it's going to improve X, and it's more of a display or more of a theoretically this would be great, see you later.
Yeah.
And hearing that it's not just for display, it's not just to prove out the theoretics, it's to actually become, the goal is to become part of the builds. I think that's amazing.
Yeah, it's been a great project to work on, and even though I'm at Delta TechOps full time now, I still am very close to my team over at Delta Flight Products. Very close with Rick and others there that are just keeping this going, and I just lend my because I have a lot of seating experience. Lend my experience where needed.
Yeah.
And 3D printing comes into that, and a ton of prototyping. The seat that we sent to Hamburg, a lot of it was 3D printed. Now the main structure was machined, but like the center console that moved up and down and everything else, the majority of all that was 3D printed. The original shrouding that went on the back of the seat was all printed on a Massivit 3D printer. So it's like a paste. So we went to a prop house. We're in Atlanta. We're in Georgia. There's a lot of film industry here, a lot of prop making. So my lead engineer on the project there, Sean Lopes, he went out and started talking with different prop houses on how we could get this rear shroud made so that it would look exactly like it needed to look. It would function exactly the way it needed to function. Now, yes, it can't go on an aircraft, but we need to convey,
right,
what is this really going to look like? How is it really going to function? How is, and make it as realistic as possible. Now the end result, what we ended up doing was actually machining the entire rear shroud out of what's called Renwood. And did that on a 5-axis CNC router. Because the design needed to change a little bit. We didn't have time to get back to printing it, and all of those type of things were internal at Delta Flight Products, so it was able to be done very quickly. But the initial prototype, fit, form, and function, even painted, was all done on a Massivit 3D printer, and then sanded smooth and painted, and was fully functional.
So cool. And you're talking about some of these different types of printers and this paste. And I know you and I touched on this a little bit, but like talking about some of the materials that are chosen. I know you said sometimes different companies will kind of select their own. We were specifically talking nylons, whether you choose nylon 12, nylon 11. What materials do you typically need to use in a project? Are you bound by the industry, or is it dependent on, if you're doing prototyping, you can pick whatever you want? How do you select a material to go into these, new projects?
So prototyping obviously is very open to material. If you're really looking at when you're prototyping, like for this seat, it's going to be shipped over. When is it being shipped over? You have to think about temperature, things like that. But your typical PLAs, PETGs, ABS, any of those for the most part will work for a prototype. But when it comes to some of the parts we make actually go in an oven, they're fixtures that will go into an oven. So we'll actually use, let's say, a high temp nylon carbon fiber. It'll be a nylon 12 with 25% carbon fiber. That's just basically a standard for the most part, 10 to 25%. And then what we'll do after is actually anneal that part. And that's taking it up near its glass transition temperature for X amount of time. Typically nylon you'll take up to, I want to say, between 120 and 140 C for 4 hours, and then let it cool down in that, while it's in the oven, you let it cool down on its to room temperature on its own. And you can typically get anywhere from 20 to 40% more temperature resistance, or your heat deflection temperature can go up. We'll do that for quite a few of our things we do internally. But when you're talking aerospace, something's going on in aircraft, it has to be flame resistant. It has to meet what's called 25853 compliance, which is in commercial terms would be like an UL 94 V0. So what we'll do, depending on where it's at in the interior, it needs to meet minimum of 12-second vertical burn. And in other cases, depending on how passenger facing it is, it has to also meet what it's called heat release requirements and smoke and toxicity. And where those are derived from is, depending on where it is, if there's a fire on the aircraft, you need to be able to evacuate the aircraft in a certain amount of time. So what the FAA will do, and other labs have done, is actually started fires in aircraft to understand how they'll propagate through the plane, how those fumes could potentially, toxic fumes, knock out a passenger and they can't evacuate, and then choose materials that will not create that toxic smoke or not propagate the burn fast enough where it gives passengers the time to get out of the aircraft safely.
That would be very fun testing. I'm just saying, not the actual fire in an airplane if I'm in it, but the testing of it would be fun.
So at Delta Flight Products, we have an FAA approved flammability lab that does vertical burn, heat release, smoke and tox. There's coupon sizes specific in the regulations for that. However, in some cases you have to burn the actual part because the part itself may be so small that a coupon isn't representative, or especially when you're injection molding. If you're injection molding something, you're not going to injection mold a 3x12 coupon as well.
Right.
In some cases I've had to do that, or we've had to do that, but there are the regulations will allow you to actually burn the actual component as well. But so we can do that, and we have done that at utilizing Delta Flight Products as our flammability lab.
Our sophomore year, we did burn parts as part of one of our labs, and I will say to this day, I do remember that polyethylene smells like birthday candles, and that's all my flammability facts I got.
You'd be surprised the interior of an aircraft what it has to go through. Cushions, actually go through what's called an oil burn. It's actually they've changed it now. It used to be kerosene, but it looked like a flamethrower going at a cushion, burning that cushion. And during that burn, that cushion can only lose a certain amount of mass, and the burn can only propagate so far across the cushion. And if that fails, then the cushion, you can't utilize that cushion material. So that's one reason on an aircraft, if you say, hey, these cushions aren't that comfortable. For the most part, we can make them semi-comfortable, but we're not allowed to use the same materials that you can use at home. And so it becomes very difficult to get the right buildups of and the right foams to utilize that aren't going to just catch on fire.
That's
the
fair.
other thing.
I prefer the less flammable version.
Yeah, I don't feel like air and like fire and like flying, sitting in a fiery plane. No, that's not for me.
So the materials that we utilize mostly, so Stratasys here's one thing. Stratasys got in early, working with Sabic on Ultem 9085, and they helped to write the SAE documents for the polymers in aerospace and basically I can buy certified grade Ultem 9085 from Stratasys that comes with the material certs, all the certifications for flammability rating with it. And as long as your machine is calibrated properly, all of that is done, you can print parts out of that certified grade material that can then go on an aircraft. Non-structural, we're talking about non-structural parts, but they meet heat release, smoke and toxin flammability to basically put that material anywhere in a cabin.
That's
a lot of Boeing prints a lot of their ducts. Like you may have a weird shaped duct. Obviously, an aircraft, you're crammed for space, and your air ducting that's up, it's going to be behind your baggage, behind your side panels, all of that hidden. Has to take weird turns, and maybe you have flexible tubing that goes through there, but you have different junctions that you have to put some kind of duct, some kind of joint to connect those hoses. A lot of that is printed out of Ultem 9085 by both Boeing and Airbus. And we actually do that. Our crew rest that Delta Flight Products makes, those ducts or connection points are also printed out of Ultem 9085.
Wow. Well, I will be taking a flight tomorrow, and I will be thinking about that probably the whole time, just envisioning what these 3D printed parts, these junctions might look like hidden away.
And I know one of the questions you guys had, do I see more 3D printing in the aircraft cabin in the future? Absolutely. There are a lot of components in the cabin that are non-structural. Think of here's just one quick one. Flight attendants, I'm sure you've all seen them when they sit down right before you're going to take off. Flight attendants, cross-check, and then, please get ready for departure. They'll sit down and they'll grab the phone. Well, that phone is on a hook, just like you'd have your old phones at home. Those break all the time. And anything that says aerospace after it or aviation after it somehow becomes 10 times more expensive than anything you put in your house. 10 times is probably being low. So those things can be very expensive, very long lead time. And, if you can't get them from the OEM, meaning the original equipment manufacturer like a Boeing or Airbus, then how do you get that part? Traditionally, it's injection molded. Only one company out there, maybe two, have a tool for it. Maybe you only need 40 of those a year versus, that's perfect volume for 3D printing. One thing I had talked to Lynzie about, there's a company called Dimension. They'll actually dye, so SLS printing, so powder. So we have a P396 EOS that is SLS, and we do print We'll do nylon 12, nylon 11. That's FR rated. Both. So Airbus has an FR rated nylon 12. Boeing has an FR rated nylon 11. We can print a part with that, send it to a company called Dimension. They'll actually dye that part to match any Pantone that you want. It's about a 6-week process. Then they make color packs. If you have their equipment, we don't, but they'll actually make these color packs that they put in based on the volume of parts that they need to dye. They'll dye those parts, they'll finish those parts will come back looking exactly like what you wanted them to look like. Now, the caveat is whatever the powdered color is does play a role in that. So if the powder's gray, you're not going to get a white part. But luckily, the FR powder that both Airbus and Boeing use is a kind of an off-white, so you can dye it to most any color. So they'll also seal it. So as we know with FDM, it's the same with SLS. It's got a porous finish to it. You don't think that with FDM, but it is. Most FDM parts, if you submerge them in water, they're going to fill with water over time. What Dimension does, and there's other companies that do it as well, they'll actually do what's called a vapor seal. So it actually completely solidifies the surface, which makes it more scratch resistant, but also makes it resistant to water completely, which comes into play if you were, let's say, going to do something that was a food contact surface in an aircraft. We've actually done Ultem 1010, which is food grade, FDA approved, printed it on an FDM printer and had worked with them to actually have them vapor finish it so that it's completely, there's no more pores in the material, it's completely sealed, so no bacteria can grow. It can be wiped off, cleaned. You don't have to worry about bacteria getting into pores and growing.
Probably cleaner than most airline surfaces that we are touching on a regular basis.
I will say cleaning on the aircraft since COVID has gotten extreme. You should never worry about touching anything in an aircraft anymore.
That's good because my kids are typically licking it, so we're already down that rabbit hole.
Oh boy, I hope. Yeah, I'm glad that my flight is before your South Carolina flight, Lindsay. Just there's no chance of me.
Don't worry, we're driving. I don't think airlines can handle all 6 of us just yet.
Well, hopefully you're flying Delta, because we have a global clean team that actually all they concentrate on is how to keep the cabin clean in between flights. How do we clean it, clean it cleanest and safest for our passengers in between every single flight. We have a whole team that's what they do.
Wonderful.
See? Now you can lick the seats too, Mercedes.
Yes. I don't recommend
I fully
it,
intend to. Yeah, I fully intend to. Well, I think we're about out of time today. But Mitch, Rife, thank you so much for joining us on the podcast today.
Yeah, I apologize. I go all over the place. When you sent me the email, it was, tangent everything. I'm tangent everything.
Well, we appreciate it. This has been a fascinating call, and I think there's easily like 15 things that we could have dove deeper into that my mind is already like spinning on. So
well, if there's any questions that come out of it, things we can do a follow-up, or you can send me questions and I can reply.
Awesome.
Anything like that, because I'm sure there could be 10 million questions that come out of this.
Always.
And I'll do my best to help answer them if I can.
All right. Well, thank you so much, Mitch.
Thank you so much.
All right. Well, thank you guys. It was great meeting you guys.
Nice meeting you.
Great talking to you.